Welcome back. This explainer is brought to you by Forge College, and I am super excited to be your guide today. So, in our last session, we got into the weeds with a theory of repository patterns and integration. Well, today we are rolling up our sleeves for a true hands-on engineering workshop. We're talking project integration with version control. Let's get right into it.
Now, here's a hard truth of engineering. Code without version control is honestly just a fragile, terrifying pile of text files just waiting to break, seriously. But by applying the workflows we're about to go over, we're going to transform all your hard work into a verifiable, rock-solid structural blueprint that any team can rely on. Okay, here's our game plan for today. We'll start by moving from theory to practice, then scaffolding the blueprint, committing for clarity, pushing for discoverability, tagging for checkpoints, and finally verifying the artifact. All right, step 1. From theory to practice, setting the stage. Think of this phase as a highly focused 30-minute guided exercise. We are strictly dealing with local to remote version control today. And just to put your minds at ease right out of the gate, there are absolutely zero Solana blockchain transactions happening in this one. None. We're focusing 100% on building those foundational development habits. To get started, you really just need the basics. Have Git installed, make sure you have access to a remote host like GitHub, and grab your favorite text editor. Oh, and I highly recommend configuring your SSH keys right now. Trust me, it saves you from those super annoying password prompts that totally break your flow later on. Moving on to step 2, scaffolding the blueprint, the initial files. Okay, we're officially on the construction site. We need to build a coherent directory layout that perfectly maps to our module boundaries. It's actually super simple. Let's look at the basic terminal commands. First, we type mkdir, project increment 1. Then we cd into project increment 1. And finally, git init. With just those 3 quick lines, you've created your workspace, stepped inside, and officially laid the very first brick of your project repository.
Now, let's furnish this space a bit. You can think of these files and folders as the structured rooms of your blueprint. Your README is the front door. It describes the whole scope of your increment. Then you have your SRC directory, which is absolutely crucial. That's where your primary module code lives, housing our self-contained example. Next up is the test folder, and that's exactly what it sounds like. It contains the scripts that verify your code's integrity. And finally, the git ignore file. Think of that as your club's bouncer. It keeps out all those unwanted editor artifacts and messy build outputs. Up next, step 3, committing for clarity, recording the process. This right here is where we turn our code base into a precise, highly readable historical log. So what exactly is a commit? Well, it's a focused, logical unit of change that has to answer 2 very important questions: what changed and why. I always like to think of a commit as an intentional mechanical gear clicking firmly into place. It is emphatically not just a frantic save button you smash when your cat decides to walk across your keyboard. This visual perfectly illustrates the difference between a pro and an amateur. Just look at the contrast. On the left, you've got a beautifully structured commit message with a crystal clear type, scope, subject format. Now look at the right. Added stuff. Yeah, that tells your teammates, and honestly, your future self, absolutely nothing. So let's see how this actually works in practice. First up, you git add your specific files. Then git commit -m followed by a meaningful message. Something like feat, example, add greeting function. A quick pro tip for you, try to keep your commit bodies under 72 characters. It makes them so much easier to read in a terminal. And hey, a word to the wise, be extremely careful with git commit amend. It's fantastic for fixing a local typo, but it literally rewrites history. If you've already shared your work, doing that can cause some massive headaches for everyone else. Let's roll into step 4, pushing for discoverability, filing the patent. All right, we've built our local draft, but now it's time to sync things up. We need to push this to a remote endpoint. Think of this process as officially filing your patent so the rest of the world knows what you've just built. And here is exactly how we file it. First, run git branch mmain to make sure your primary branch is named correctly. Next, git remote add origin, followed by your specific repository URL. And finally, git push -u origin main. By using that -u flag, you're establishing upstream tracking. That paves the way for super smooth, seamless collaborative handoffs down the road. Step 5, tagging for checkpoints, the official stamp. Okay, so our code is now remote. Next, we need to create a release marker. This is essentially an unmoving stamp on our completed increment. You basically have 2 choices here: On the left, we have annotated tags. These bad boys contain metadata, like the author and the date, making them incredibly robust. They are the absolute standard for real increments. On the right, we have lightweight tags. These are just simple text markers. They're totally fine for a quick local pointer, but they definitely lack that true engineering rigor.
So here is the exact command you'll use to create that explicit version marker using an annotated tag. You'll run git tag-a v1.0.0-increment1, followed by your descriptive message. And hey, after you create and push that tag, do not forget to update your README. You need to document exactly what this specific increment covers. Always leave a clear trail for the next engineer who comes along.
And finally, step 6, verifying the artifact, the final inspection.
We've built it, we've recorded it, we've pushed it, and we've stamped it. Now, I'm going to put on my strict inspector hat for just a second to make sure this blueprint is fully operational. We've got 4 things to verify. Number 1, is the repo initialized? Run ls-la and look for that .git folder. 2, do we have descriptive commits? Run git log-1 line and check for focused messages. 3, is there a release tag? Run git tag-l to find it. And 4, are we synced remotely? Run git remote-v. Oh, and if you notice your tag exists locally but not remotely, don't panic. A simple git push origin fixes that instantly. Let's do a really quick recap. 1, commit for clarity. 2, tag for checkpoints. 3, push for discoverability. These 3 core principles should absolutely guide all of your future repository work. It drastically reduces ambiguity when handing off projects. By the way, as you dive into the various learning paths and programs we offer at Forge College, you're going to see these exact version control principles applied time and time again. They really are the absolute bedrock of reliable engineering.
So, I have to leave you with a bit of a provocative question to chew on. Is your artifact actually ready for the comparative capstone? I'm asking this to bridge right into our very next lesson, which is managing versions and preparing for comparative capstone. Make sure you're keeping those repositories tidy because everything you built today is going to be put to the test very, very soon.
And that officially wraps up our explainer on project integration with version control. Be sure to head over to forge.college today to dive even deeper into this subject. You can explore a ton of other Web3 educational resources and see firsthand how mastering these robust fundamentals will supercharge your entire development journey. Keep building, keep committing cleanly, and I will catch you in the next one.